I will talk about operator overloading for user-defined class. In this video, we'll start with the arithmetic operators such as plus, multiplication, etc. So we've already seen that in Python, the built-in types such as int and list, they can use the operators, special syntax such as plus in the square brackets, just by calling the appropriate dunder methods for those types, right? So that means on the flip side that if the user-defined class, the class we defined, if we define the appropriate dunder method, then our class can use these special syntax as well. And so we will show how to do that by defining a vector class. So for just a quick review of what a vector is, a vector, well, at least in a two-dimensional vector, it's just a really it has a direction and a magnitude on an x and y plane, and this is, this blue line is one vector, and because it's on an x and y plane, it has an x, the vector has an x component, so ax here, and also a y component. So to represent a vector, we can just define, the vector class. Then the dunder init method takes an xy component as the parameter and create xy attributes. And for the string, we can just print out x and y. So I've already instantiated two vectors here. A is 1 and 2, and B is 5 and 6. So the next step we want to see is how do we add two vectors together. Now, vector addition is fairly straightforward. So we have two vectors here, A and also B. And when we add A and B and the resulting C, then the x component of C is basically the x component of A plus the x component of B. And the same thing, the y component of C is the sum of the y component of A and the y component of B. So, so that's the mathematical definition. Now, however, if we do the addition right now, we will get the unsupported operands for this plus, because, well, the class as we defined right here with just the dunder init and dunder string, it doesn't know how to do the addition, right? So now let's define the dunder add method. Now the dunder add method takes two parameters. One is self, one is other. So you might be wondering, what is self, what is other? So let's print that out first. And there we go. So let me run it. So in this case, self is the vector 1 and 2, other is the vector 5 and 6, and that's A and B. And remember, the reason the dunder add method is called is because we are doing an addition between A and B, which both are vectors. And if you remember from a previous video, that this is equivalent to A dot add, and the parameter is B. Okay, so these two are equivalent, and if you look at actually this syntax, then it might be very obvious that self, right? Self in the dunder add method is the vector A, which is 1 and 2, and the other in the dunder's adds parameter is B, and that would be 5 and 6. Now, so right now it says C is none because in our dunder add we didn't return anything, right? We only printed something else. So in order to actually return a useful result other than none, we know we're going to construct a new vector, okay? Because typically addition, I mean, it should give a new number, right? Rather than modifying the two operands. So we're going to construct a new vector that needs a new x and a new y, right? And remember, to add two vectors together, we're just adding the x's of the two vectors together and the y's of the two vectors together, and that's why new x and new y, and that's the definition for that. So now if we run it, we get this, and well, that's because I do too many prints here, and I should not call this twice. So this should look prettier. There we go. All right, so yep, that's what this slide is trying to say. I think both of these, and that's the result. And right, so one more thing about the done the add method is that what if other is not a vector? Then right, we don't really know what to do. So it's sometimes it's a good idea, and sometimes it's necessary that we actually check to make sure other is the right type. Now I could very easily say vector for this, but instead I don't want to hard code the name vector in there, so I'll just say I'm making sure other is an instance of the class of myself, which is this is the same as same vector. And I would just say if it's not an instance of a vector, then I would say other should be a vector. Here is a string. That's the name of the class that self is. So now I am going to ask you to give this a try to define vector subtraction. When you're subtracting two vectors, you are basically subtracting the individual x's and y's of the two vectors, pretty much like the vector addition. So and for the for subtraction, we define the under sub method. So please define it and make sure that it works. All right, so hopefully you've done that, and here is the code, fairly straightforward. And here I didn't do the type check, but it's a good practice to do so. So next, let's try to implement multiplication for vectors. Now there are several different ways of doing vectors multiplications. There's what's called a dot product and cross product, but we're not going to do it for our demonstration purpose. So instead, let's do something fairly simple, and that is we are going to implement vector multiplication by a scalar, or just a number, right? Rather than multiply two vectors together, we're going to multiply a vector with a number. And the resulting vector is just each of the x and y component of the vector multiplied by that number. So if you want to give this a try, you should know how to do this already. So pause the video and try it out. Otherwise, here's a definition. Well, or this is the use case, and the definition is we are going to define the under mode method, because that's multiply, right? And the same thing, it has a self and other, the two things that we're trying to multiply together. Now, so hopefully by now you know that self would be the vector itself, and in case for this one, the other, like at least in this syntax, the other would be the number 3. So I am actually going to make sure that other is a number. So I'll say if it's not, and if instance is not an instance of numbers not number. Now this numbers not number actually allows me to check that it's either an int or a float. So both of those are numbers, right? So that's why I use this. If it's not an instance of a number, then yeah, there's a type error. Otherwise, I'm just going to create a new vector, and the new vector's x is the current, the original x multiplied by other, the number, and the y multiplied by other. So I've already typed this out here for mole, and as a matter of fact, I cannot rename other to scalar and use that. So if we run this, we know that, yep, it's if we multiply a vector that is x is 1, y is 2 by 3, then the new vector is x is 3 and y will be 6. So so far so good. Now, one thing about multiplication is that we expect it to be usually commutative, meaning if we switch the order of the two operands, the result should be the same. So if we do that, if we put a 3 in front of the vector A, and if we run that, we, however, get a type error exception. So why is that? And the reason for that is if we look at what kind of Thunder method call this turns into, now 3 is an integer, so multiply meaning we call the int Thunder mode method and pass the vector A as the parameter. Now int obviously can be multiplied with other int or other numbers. However, it would have absolutely no idea what to do with a vector. And that's why this type error is raised. That it says it just doesn't know how to handle for multiplication a operand type that is int, and the second operand type is a vector. All right, so how do we handle cases like this? Well, one way is if the problem were with in standard mode that it doesn't know how to handle a parameter of the type vector, then we can we override it and so to make it work with a vector? Well, we could, but it's int is a built-in type. It's usually not a good idea to change the behavior of the built-in type. Now, fortunately, there is a better way to do it, and because the problem is really with the new type of vector, right? So we can actually define a Dunder mode method, but it's not quite the same as the regular mode. It's what's called the R mode method, and I guess it means the reverse multiply method. So let's actually first print out what self is and what other is, so that we understand better what we're dealing with here. Other. Okay, so let me run this, and as you can see, now this function actually, the R mode actually gets called in this case. And what the self is self is the vector, and other is 3. And the reason that is the case is because this is the same as a dot R mode multiplied by 3. So let me run this again. And we actually get this thing printed out twice because, again, these two statements are doing exactly the same thing. All right, so now that we know this method gets called, then what is the result? Well, self is the vector and other is the scalar, so it's really exactly the same as that. So we could just return, do exactly the same as the regular Thunder mode method, and that would hopefully works. Yes, it does. So now we can handle a number multiplied by a vector. Now, if you look at this, this is really the two are exactly the same now, right? So I can simply just do self multiplied by other, right? And again, because self is a vector, other is well, just by the fact that self is the vector and multiplied by something, it would automatically call the Thunder mode method, and it would know, and then this would just return what does what it does regularly, right? So that is that also works, and it's a better way to write this just because, okay, if we decide to change, update this regular mode to do something else, then we don't have to change what the Thunder R mode does. Right. I think that's what this slide is trying to say. So just as a quick summary, what happens in this case when we do multiplication of an int with a vector is that Python actually tries to do the int dunder method first, and that dunder method, it looks at the type of a, which is a vector. It just doesn't know what to do, so it probably raises, well, it raises a type exception, right? Now, when Python sees an exception raised by this, the dunder mode method, it actually tries another thing. Then it tries to go to the second operand, in this case, the vector, and it will try to call the second operand's dunder mode method. And in this case, we define it, and it will do the thing that we wanted to do, and in this case, it will succeed. And inside mode, we call the regular multiplication because again, we want the multiplication to be commutative, so we can switch the order of these two operands. So now I would like you to give this a try, that to define the operation for the true division, the single slash, the method to override is dunder true div. And for a vector, we only define it for a vector divided by a number, so divided by n, and that is each of the component x or y, or x1 and x2, divided by the scalar. So please give this a try. Okay, so assuming you've done that, here is my approach. So you could very well construct a new vector with the x and y divided by the other, right? But my approach is to take advantage of the fact that if you divide by n, it's the same as multiply with the reciprocal of n, and that's what I did here. So, and this is the test code to prove that it indeed works.